So, hello and welcome to our presentation of a series of programming questions related to civil engineering concepts. As part of our final examination, we were tasked to use C++ language in solving different problems associated with civil engineering. So, we have here on the first problem, write a C++ program to calculate the volume and surface area of a structure. The program should take the length, width, and height of the structure as inputs from the user and display the calculated volume and surface area. So, for us to have an overview with the overall steps or sequence of the program, we have created first what we call the algorithm or the pseudocode, which shows a step-by-step process of the program. So, it is where we have written the instructions which describes how we perform the task, particularly in calculating the volume and surface area of a structure, considering its length, width, and height. So, on step 1, the user will input the length, width, and height. Then, on step 2, it will be multiplied. The length, width, and height will be multiplied with each other and will be stored in a data which is regarded or presented as volume. So, for you not to be confused, this formula is actually the actual formula on the volume of a rectangular prism. Then step 3, the user will input the volume. Then on step 4, another formula is introduced, which is the sum of length times width, length times height, and width times height multiplied by 2, which is the actual formula for the surface area of a rectangular prism. Then on step 5, the surface area is the input. So, the next part is what we call the flowchart. So, our flowchart here clearly shows a sequence structure which demonstrates a line-by-line execution on which the statements are executed sequentially. So, in the same order as they appear in the actual program or the actual codes once I execute it later on this part of the video. So, on our flowchart, of course, we have different shapes which represents a specific task or function that will be executed throughout the program. So, at first, we have what we call the terminal, which signifies a start. And then we have the input, which is represented by a shape called parallelogram, which basically shows a message displayed to the user asking them to enter the length, width, and height of the rectangular prism or the structure. And then, of course, it is in meters as the unit. So, we also have here a rectangle which represents the process on which calculation of the volume and surface area is considered, which will then lead in displaying the actual calculated volume and surface area of the structure. So, and then I will now proceed in discussing the codes which we compiled using the dev C++. So, on the first line of code, we use the hashtag include IOStream, which is called a header file library. This code is basically allows us to work with the input and output objects, or to make it simpler, this header file adds functionality to the C++ program. So, the second line here is also called a header file. However, its function is intended to perform mathematical operations as we are required to calculate the volume and surface area. So, on the third line, of course, we will not forget to include the abbreviation for standard or the using namespace std, which basically allows us to name objects and variables on the program. So, and of course, do not forget to use the int main, because it is a function which allows anything or any code inside of its curly brackets here to be executed. What I mean is that everything inside every code or inside this curly brackets in the int main is the one to be executed once I run the actual code or program. So as I have mentioned earlier, the structure that we have chose to find its volume and surface area is the rectangular prism, since it fits with the instruction that the length, width, and height should be considered in calculating the volume and surface area. So first, we declared all the variables that will appear throughout the code. Since the length, width, and height is considered, then we also use this particular aspect in defining the variable. So this length, width, height, volume, and surface area is what we call the identifiers, or the unique names of the codes for it to be easily maintained and utilized or understood by the programmer. So and by the way, we have utilized double as a variable function because it is far more accurate and precise on a 15-digit scale, which is ideal for most of our calculations. And then of course, we will ask the user to input the length, width, and height of the structure. So on this particular part of the code, we have utilized the cout, or what we call the display variable, which basically prints the text that asks the user to enter the length, width, and height of the rectangular prism or structure in meters. And then for the user to actually input the length, width, and height, we have utilized the character input or the user input, which is on this part with using the insertion operator. While the cout is basically what we call the extraction operator. Of course, we do not forget to make use properly of the semicolons, for it signifies the end to each line of code. Otherwise, we would get many errors once we execute the actual program. And also, we have utilized end line function, particularly to break line of codes in making the code execution neat and organized. And of course, once we have obtained the length, width, and height in meters from the user, then the program will then proceed to in calculating the volume and surface area of the rectangular prism by this formula for volume, which is length, width, and height multiplied together. And of course, once it has been calculated, a message will be displayed to the user which shows the calculated volume of the rectangular prism in cubic meters as its unit. Then of course, we have the surface area, which has the formula of twice of the sum of the length times width plus length times height plus width times height. And then of course, it will display the message which shows that the surface area of the rectangular prism is in the variable surface area for surface area, and of course its unit is in square meters because it is an area. And then we have this return 0, which signifies the end of the program. And then for us to visualize what I have discussed in this code, I will now execute the codes. As what I have mentioned earlier, it will ask for the length, width, and height of the rectangular prism. Let us assume that the height of the rectangular prism is in meters. So let us assume that it is 34 meters. And then the width to be 40 meters. And then the height to be 78 meters. And then once I press enter, as you can see here, it has displayed the volume and surface area of the rectangular prism. The volume of the rectangular prism is about 106,080 cubic meters, while the surface area is 14,264 square meters. So for it to be sure, I will try it once again with different values for the length, width, and height. Let us say that it is in larger number, like 789 in length, 456 in meters, and 980 in height. So as you can see, it has displayed actually the volume and the surface area of the rectangular prism. But as you can see here, it is on a larger scale or number, since I have put a large number for the length, width, and height. So as you can see here, the program is working properly as it considers the length, width, and height of the specific structure, and it calculates the volume and surface area.
In problem number 2, we are asked to write a C++ function named calculate steel quantity that takes the following parameters, which are the length, representing the length of a steel bar in meters, diameter, representing the diameter of the steel bar in millimeters, and quantity, which is a reference parameter to store the calculated quantity of steel bars required. There is also a reminder that functions should calculate and store the quantity of steel bars required to cover a given length, considering the following conditions. First is that each steel bar has a fixed length of 12 meters, and second is the steel bars are placed side by side without any gap. So this is the algorithm for problem number 2. First, we will start the program and then we will declare a void function named calculate steel quantity with parameters length, diameter, and quantity. Inside this void function is the declaration of a constant variable named length bar with the value of 12. We'll also convert here the diameter from millimeters to meters by dividing the diameter in millimeters by 1000 and assign the value to the variable diameter underscore m. We will also calculate the quantity by dividing length to be covered by the product of length bar and diameter underscore m. There is also a condition here that if the difference between the length to be covered and the product of the quantity, length bar, and the diameter underscore m is not equal to 0, then the quantity will increment by 1. And if not, you will just it will just display the quantity, or it will stay as is. And in step number 3, uh, the main function will start. We will get the input from the user for variables length and diameter. And then after that, we will call the function calculate steel quantity with the arguments length, diameter, and quantity. And with that, we can calculate the steel bars required for that specific length to be covered. And then we will display the message the quantity of steel bars required is followed by the value of quantity. And with that, the program will end. So this is the flowchart for problem number 2. The program will start, and then um, it will display a message asking the user to enter the length to be covered in meters, and after the user inputted a value, it will be stored, or it will be assigned into the length variable. And after that, another message will also display asking for the diameter of the steel bar in millimeters, and the same step with the first one. After the user inputted a value, it will be assigned in the diameter variable. And with that, we will call the calculate still quantity, or the void function calculate still quantity with the parameter length, diameter, and quantity, wherein in this function, it is stated that the length bar is 12, that there will also be a conversion for the diameter, and the formula for the quantity. And for this is the condition if the length, or if the difference between the length to be covered and the product of the quantity, length bar, and the diameter underscore m is not equal to 0, then the quantity will increment by 1. And if not, it will just display the quantity. And after that, the program will end. So as you can see, the first thing that we put is hashtag include iostream, known as the header file library, which provides functionality in our input and output operations throughout the program. In here, we already stated using namespace std to avoid hassle in writing std before standard library names. In line number 4, we created here a void function entitled calculate still quantity that takes three parameters that I have mentioned earlier, which are the length, diameter, and the quantity. And for your information, void function is a function that doesn't return a value and does not require a return statement, unlike the main function. In line number 6, we stated const double length bar equals 12, which means that this line defines a constant variable named length bar representing the fixed length of each steel bar in meters. And since the provided fixed length of each steel bar is in meters and the diameter is in millimeters, we decided to convert the diameter from millimeters to meters by dividing it by 1000. And the answer from it, or the result from it, will be assigned to the variable diameter underscore m. In line number 12, we stated the formula in getting the quantity. So this line will calculate the number of steel bars required by dividing the length to be covered by the product of the fixed length of each steel bar and the converted diameter in meters. So after executing this formula, the answer, or the value that we'll get from this, will be stored in the quantity variable. And for the last part of this avoid function is the if statement. So this if statement is for the adjustment of the quantity, wherein if the difference between the length to be covered and the product of the calculated quantity, fixed length of each steel bar, and the converted diameter is not equal to 0, it increments by 1. So in simple words, if there is a remainder after executing this formula, the quantity should increment by 1, indicating that we still need an additional steel bar to cover the remaining length. And here comes the main function. So in here, we declared the three variables, which is the length to be covered, the diameter, and the quantity. So as you can see, we use double for the length and diameter, since these variables can sometimes be in a decimal number, while on the other side, we use integer for the quantity, since we are talking here about the number of steel bars required. So meaning to say, it should be in a whole number, not on a decimal number. So in this part, we prompted the user to enter the length to be covered in meters and the diameter of the steel bar in millimeters, and the values inputted by the user will be stored in the length and the diameter variable respectively. In line number 31, we output new line character so that there will be a gap or a space in between. And this part, as you can see, we stated and called the function that we created at the first part of the program, wherein this function will calculate the steel quantity and update the quantity variable. And for us to display the steel bars required, we printed the value of the quantity. And lastly, the return zero, which means or which indicates that the main function is already done executing. So with these codes, we already have our output. So enter length to be covered. For example, I am going to put um 12 meters, and then the diameter of the steel bar in millimeters is also 12. So the quantity of steel bars required is 84. And it's already done.
I'm back. So, on problem 3, we are tasked to write a C++ program to calculate the bending moment of a beam based on the applied load and distance from its support. So, the program here should take the following inputs from the user. First is the load, which represents the applied load in kilonewtons as the unit. And of course, the distance, which representing the distance from the support to the point of intersect on the beam in meters. So, also, we are instructed here to assume the following conditions for the load distribution. So, the first condition is that if the distance is less than or equal to half of the beam length, then the bending moment is calculated as load multiplied by distance. However, on the second condition, it states that if the distance is greater than half of the beam length, then the bending moment is calculated as load multiplied by the difference between the beam length and the distance. And then the program should display the calculated bending moment of the beam. So to approach the problem, or to actually solve this problem, the first step that we visualize is in making the algorithm or the pseudocode. For us to visualize the steps in solving the specific task of this problem, we have first created or formulated what we call the algorithm or the pseudocode. So, in formulating this algorithm, we are basically establishing the blocks for our programming. And of course, for us to determine such processes and conditions or decisions in calculating the bending moment on this problem. So, on step 1, we will ask the user to input the load, distance, and the beam length. Then, as you can see here on step 2, we have a condition as what is specified or instructed on the problem that if the distance is half of the beam length, then the bending moment is calculated by multiplying the load by distance. Else, if this first condition is not satisfied, then the bending moment is load multiplied by the difference between the beam length and the distance. So, on step 3, of course, the final output is that the system will display the calculated bending moment of the beam. Then, for us to have an overview with the overall steps or sequence of the program, we have created first, next is the flowchart. So, our flowchart here clearly shows a sequence structure which demonstrates a line-by-line execution on which the statements are executed sequentially in the same order as they appear on the actual code. So, it is where we have set instructions in calculating the bending moment, considering that we have the following assumptions or conditions which I have mentioned previously on the algorithm. So, here as you can see on our flowchart, we have different shapes which represents a specific task or function that will be executed throughout the program. At first, of course, we have the terminal, or which signifies the start, and then we have the inputs represented by parallelograms. Basically, it shows a message displayed to the user asking to enter the load in kilonewtons of the beam, its distance from the support in meters and also the length in meters. However, as you can notice here on this part of our flowchart, it is what we call a decision structure, which is represented by a diamond. In this structure, one of the following or one of the two possible actions is taken depending on the condition. First is that if the distance is less than or equal to 0.5 of the beam length, if this condition is satisfied, or if it is true, then the bending moment is calculated as load multiplied by distance. However, if it is false or it is not satisfied, the bending moment is calculated as load multiplied by the difference between beam length and distance. And then of course, the last part is where the beam's calculated bending moment is displayed to the user. And then proceeding to the actual codes of this specific problem, as you can notice here on the first line of our code, we of course use the hashtag include IOStream, which is called the header file library, which basically allows us to work with input and output objects, or to make it simpler, it adds the functionality to the C++ program. So on the second line, we use what we call the standard abbreviation, which basically allows us to name objects and variables on our program. And of course, we do not forget to include the int main, because it is a function which allows anything inside of its curly brackets or any of the codes to be executed. And then here we then declare the variables, which is the load, distance, beam length, and the bending moment. And then as you can notice here, we have utilized double because it is far more precise, up to 15 digits, which is ideal for most of our calculations, as we would deal with calculating the bending moment. And then of course, we will ask the user to enter the load, the distance in meters, and the length in meters. And of course, we will send a message to, or display that message to the user by utilizing what we call the cout, or the extra insertion operator, which basically displays the variable or text. And then of course, we would ask them to input or enter the said parameters, which are the load, distance, and length, by utilizing a code which is called the character input, or cin, as the extraction operator. And of course, we do not also forget to use semicolons properly, for it signifies the end on each line of code. Otherwise, we would get many errors as we execute it. And also here we have utilized what we call the end line, no? Which is intended for us to break lines, particularly in making the code execution neat and organized. And of course, once we have determined, or once we have obtained the load, distance, and length, the program will proceed to considering the following assumptions. So, however, since we have assumptions to take into considerations on this particular part of our codes, we have utilized what we call the C++ conditions, or what we call the if-else statements. So it is basically a logical condition that if the distance is less than or equal to 0.5 of the beam length, then the program will proceed in calculating the bending moment using the formula load multiplied by distance. Else, if the first condition is not satisfied, then the bending moment is calculated as load multiplied by the difference between the beam length and the distance. And of course, once it is calculated, a message will appear to the user that the bending moment of the beam is calculated with the unit of kilonewton meter. And then of course, we would put the return 0 as it signifies the end to our codes. For you to better visualize or to understand better the codes that we have written here, I will run it and test some test values. So let us assume that the load of the beam is to be 45 kilonewtons. And of course, since distance is what we is the main factor in the condition that we have written here on our code, let us assume the distance to be 0.5 meter. Then the length to be, let's say that it is 20 meters, then the bending moment of the beam is 22.5 kilonewton meter. So basically, the calculation of the bending moment is done using the formula of load multiplied by distance, since it satisfies the condition that the distance is less than or equal to 0.5. But then let us test again using a different value of distance which satisfies the else condition. So let us assume that the load is 75 kilonewtons. The distance is, let's say that it is 3 meters. And the length to be 127 meters. So then the bending moment of the beam is said to be 225 kilonewton meters. So basically, it satisfies the else condition here, wherein the distance is not less than or equal to 0.5 of the beam length. So basically, the formula that was used or in calculating the bending moment here is the load multiplied by the difference between the beam length and the distance.
Problem number 4, determining the type of soil based on its moisture content. This is the algorithm of problem number 4. Step 1, input moisture content of the soil in percentage. Step 2, if moisture content is less than 10%, then display dry soil. Else, if moisture content is greater than 10% and less than 30%, then display moist soil. Else, if moisture content is greater than 30% and less than 60%, then display wet soil. Else, display saturated soil. Step 3, display soil classification and the program. This is the flowchart of problem number 4. Start, then display enter moisture content in percentage, then input moisture content, then if moisture content is less than 10%, if yes, it is a dry soil, if no, then proceed. If moisture content is less than 30%, if yes, it is moist soil, if no, then proceed. If moisture content is less than 60%, if yes, it is a wet soil, if no, it is a saturated soil. Then end the program. Problem number 4, write a C++ program to determine the type of soil based on its moisture content. The program should display the corresponding soil classification based on moisture content. In this program, we will first declare the variable moisture content to store the moisture content of the soil as a percentage. Then enter the moisture content using the cout and receive the input using cin. Then next, we will use series of if and else if statement to determine the soil classification based on the moisture content. Each if condition checks the range of moisture content and display the corresponding soil type. If moisture content is less than 10, cout the soil is a dry soil. Else, if moisture content is less than 30%, cout the soil is a moist soil. Else, if moisture content is less than 10%, 60%, cout the soil is a wet soil. Else, cout the soil is a saturated soil. Then return 0 to end the program.
So for problem number 5, we are tasked to write a C++ program to calculate the total load on a bridge. The program should take the following inputs from the user: num trucks representing the number of trucks crossing the bridge. And for each truck, the program should ask for the following inputs: truck weight representing the weight of the truck in tons, truck axles representing the number of axles on the truck. And we should assume the following load distribution factors based on the number of axles. For trucks with two axles, 40% of the weight is distributed to the front axle and 60% is distributed to the rear axle. For trucks with more than two axles, 30% of the weight is distributed to the front axle and the remaining weight is distributed equally among the rear axles. So the program should calculate and display the total load on the bridge. So this is the algorithm for problem number 5. And first we will start the program, and then on the second step we will declare num trucks, truck weight, truck axles, weight FA, weight RA, total load, and some variables. So these are the variables all throughout the program, or the variables that we will use throughout the program. In step number 3, we will get the input from the user for num trucks, or the number of trucks. And then we will initialize the sum variable to 0. In step number 5, there will be a loop, a for loop to be specific from the loop variable I starting from 1. And then in here, we output truck number I for the labeling or the truck numbering. In 5.2, we will get the input from the user for the truck weight. Also, we will input, or we will ask the user for the truck axles, or the number of the axles of the truck. And in here, there is an if statement that if the truck axles is equal to 2, then the weight of the front axle is 40% of the truck weight, and the weight of the rear axle is 60% of the truck weight. And if the truck axles is not equal to 2, the weight of the front axle is 30% of the truck weight, and the weight of the rear axle is 0.70 or 70% of the truck weight. After executing after executing this if statement, we can finally solve the total load of the truck by adding the weight of the front axle to the weight of the rear axle. And after that, the total load will be added to the sum variable to get the total load of all the trucks, or the total load of the bridge. And for step number 6, we will display the message: the total load of the bridge is some tons. So in here, we will print the value of the variable sum. And for the last step in this program is the end. This is the flowchart for problem number 5. First, we will start the program, and then we will display the message enter number of trucks. And after the user inputted the value for this part, it will automatically be stored in the num trucks variable. And then in here, as you can see, the I increments. So meaning to say, there will be a loop that will happen, for loop, to be specific. And for example, the user inputted two number of trucks, meaning to say that this part will appear on the screen 2 times. So in here, we display the message enter weight of the truck tons, and then store the inputted value in the truck weight variable. And after that, we all also display the message enter number of axles, and then the inputted value will be stored in truck axles variable. So in here is the situation wherein if the track axles is equal to 2, the weight of the front axle is 40% of the track weight, and the weight of the rear axle is 60% of the track weight. While if the track axles is not equal to 2, the weight of the front axle is 30% of the track weight, and the weight of the rear axle is 70% of the track weight. And as you can see, or as you may notice, we use a connector here since our flowchart cannot fit in just one page. So after that, we can calculate the total load by adding the weight of the front axle to the weight of the rear axle. After that, the total load will be added to the sum variable to calculate the total load of all the trucks or the total load of the bridge. And for the last part, we will display the message, the total load of the bridge is some tons, and then we will end the program. This is the code for problem number 5, and as always, hashtag include IOStream, which provides functionality to input and output operations, and also using namespace std to avoid hassle. So this is the main function, and as you can see, we declared 7 variables. Num trucks representing the number of trucks, truck weight representing the weight of the truck axles representing the number of axles of the truck, weight FA representing the weight of the front axle, weight RA representing the weight of the rear axle, total load representing the total load of the truck or the current truck, and the sum representing the total load of all the trucks or simply the total load of the bridge. So in this part, we prompted the user to enter the number of trucks, and as the user inputted value, it is automatically assigned to number trucks variable. And as you can see, we outputted new line character for the spacing. So in line 18, this line starts a for loop that iterates num tracks with I being the loop variable starting from 1. So the purpose of line 19, this line is for the truck numbering or truck labeling. So in this part, we prompted the user to enter the weight of the truck in tons and enter the number of axles. So as the user inputted values to both of this, it will automatically store into the truck weight and the truck axles variable respectively. Another new line character. And as you can see here, in this part, this calculates the weight of the front axles and the rear axles depending on the number of axles of the truck. So it is stated here that if the truck axles is equal to 2, the weight of the front axle is 40% of the truck weight, and the weight of the rear axle is 60% of the truck weight. While if the truck axle is not equal to 2, the weight of the front axle is 30% of the truck weight, and the weight of the rear axles is 70% of the truck weight. So in line 36, the total load is calculated, or the total load of the current truck is calculated by adding the weight of the front axle and the rear axle. And in line 37, total load is added to the sum variable to accumulate the total load of all the trucks, or simply total load of the bridge. So another new line character. And for this one, for us to display the total load of the bridge, we printed the value of the sum variable. And for the last part, the return 0, which indicates that the main function is already done executing. That would be all. And with this code, we have our final output. So enter number of trucks. For example, 2 trucks. So truck 1, enter weight of the truck 25. Number of axles is 2. Enter weight of the truck 35. Enter number of axles 3. So the total load of the bridge is 60 tons. 60 tons since 25 and 35 is 60. It's right.